You guys can do it. 1.3, example number 1. Taking notes.
No, it's not, because look, it's the same sample right here.
Plug in two ounces or.
We're going to talk about exponential functions next. So as you guys are finding out, this is pretty much stuff that you guys learned in pre-calc, but it's a little more amped up, right? It's a little more intense. So just to kind of remind you what an exponential function is, it is a function where we have a base of a raised to a power. So this is usually called the base. All right? And so the next thing that we need to remember, now remember, if you guys write down what I write down, I'll count it as notes, and I'll skip some of the stuff. I want to write down some of the rules though real quick. So these are some shortcuts for powers and exponents. If I say a to the x times a to the y, then that's the same as a raised to the x plus y. If I say a to the x all over a to the y, that's the same as a to the x minus y. If I say, and notice all these have the same base, if I say a to the x raised to the y, that's the same as a to the x times y. And then another version of this would be if I said a to the x b to the x, I could separate that and say a times b raised to the x. And the last one will be a over b raised to the x is the same as a to the x over b to the x. And there's some more rules, but that's kind of what we need to get us started for today. And we covered this in pre-calc. Now, what's nice about the exponents is that almost any function can be modeled by a polynomial function, which is something raised to a power of x, right? And so we use these rules a lot in calculus because there's actually a power rule when we take derivatives, and it's very helpful. And so sometimes we'll take very complicated functions and we'll make them a polynomial function, which is very close. And then we can take the derivatives using the power rule. So first, let's talk about how to graph this. So can I move on to the next thing? Just write it down. I think, yep. I'll write it on the bottom here. And so we're actually going to do it on the calculator anyway. So for example number 1, we're given the function y is equal to 2 times 3 raised to the x minus 4. Now, this is an order of operation thing. It's not 6 raised to the x minus 4. We have to do the exponent first. So whatever value I plug in for x, we have to raise that first, then multiply by 2, then subtract by 4. And so we can graph this in our calculator. I don't remember whose calculator I have, but thank you. So if I come in here and I go to graph this bad boy, I'm going to clear that out. I'm going to say 2 times the quantity 3 raised to the x, close my parentheses, minus 4, and then hit graph. And so this is what the graph looks like. That's pretty easy. And so what did they ask us to do? Graph the function, state its domain and range. Well, what you'll see here is that the domain for all x values is basically going to be negative infinity to positive infinity, because although this climbs rather quickly, there are no limits or no boundaries on x. I could plug in any number for x here and it'll be a really big number, but it'll be a number nonetheless. So now for the range, well, we have some limitations there. What's 3 to the 0 power? 1. And so that could be 2 minus 4, which is 2, right? Negative 2, negative 2. And so we've got to determine what is the lowest value. Can I ever make this close to 0? Could I make this close to 0? I could. If that's a real, like if this was a negative exponent, like negative infinity, it'd be 1 over 3 raised to the infinity, which is be 1 over infinity, which would be close to 0. So the lowest value I could get close to would be negative 4. Does that make sense?
Wait, Mr. Adam,
Yes.
what's the purpose of typing in the 0 for all the x?
I'm not quite sure I understand your question there.
Because like for the previous example we did on the homework, and then this one, you said for like to find domain, you have to type in the x, like 0 for x.
Yeah, so what we're looking at is we're looking at the behavior of the graph. So domain are the x values and y is the range. So if I start going in that negative x direction, what do you notice about the y? It's negative 4, negative 4, negative 4. Now that's rounding. That's an approximation. That's not the actual thing. If I were to go in and check her settings, it would be like 4 point something, something, something. Her calculator's rounding it to negative 4. But it never goes below that. Now, if we go in the other direction, her y values grow quickly. Now, if we plug in 0, at 0, we're going to get negative 2. So with this exponent, here, if I plug in 0, it'll be 1.
Yeah.
And if I plug in negative numbers, it'll approach 4. And that's what I was saying. I probably should have showed it on the calculator.
But why wouldn't the 4 be